From Informa Tech Target, I'm Beth Pariseau, and this is IT Ops Query. This podcast distills the signal from the noise about enterprise software development and platform engineering. Each week, we'll talk to expert guests about the latest tech industry news and trends that engineering and IT leaders need to know. Don't forget to subscribe to IT Ops Query for more conversations on AI and the future of the enterprise digital workspace. Erwan Menard spent 6 years at Google, where he most recently worked as Director of Product Management for Google's Cloud AI services. In that role, he was responsible for the Vertex AI portfolio, including the Vertex AI platform, search, and agent space, now Gemini Enterprise. In August 2025, Menard left Google for Crusoe Cloud, a neocloud provider where he is Senior Vice President of Product Management. Crusoe Cloud began operations with a few A100 servers in a Montana data center in 2022 and has since expanded to building and managing hyperscale AI factories, most notably the Stargate 1.2 gigawatt data center campus in Abilene, Texas. Crusoe, which focuses on sustainable energy sources, also hosts its own AI cloud services, including managed inference. Welcome, Erwan. Thank you so much for taking the time with us.
Yeah, thank you. Thanks, Beth, for having me.
So, what prompted you to leave Google for Crusoe? Why now?
I think it's very much about the incredible forces at play between demand for AI and then the challenge of reinventing everything. I was lucky to start AI before the ChatGPT moment, like predictive AI. And then I saw the whole industry getting so much traction with everybody becoming a potential user or developer of AI. And so that combination of demand with the need to reinvent everything, not only the software stack, but the hardware, the engineering of the data center, the energy sourcing, that creates a very unique opportunity to dedicate yourself to that challenge. And at a neocloud like Crusoe, you get to do that, and that only in a very purpose-built fashion, which is very fulfilling.
Yeah, you really had a front row seat to that tsunami of change that hit the industry. So how does managing services in a neocloud differ from running them at Google?
Yeah, well, I think it's really about the dedication, basically. Like when clients call us, anybody at Crusoe does AI and AI only. And don't get me wrong, I think hyperscalers are amazing, all-purpose clouds. They can help enterprises completely transform them digitally. And I think this is terrific value and has helped the industry a lot. It just happens that AI is no more one more workload you need to accommodate. If you look at the demand that AI is putting on every layer of the infrastructure, you really need to design for it. And actually, in terms of volume of everything you're going to do in cloud, say 10 years down the road, AI will be the dominating workload. So there is an opportunity to serve those workloads in a very purpose-built, dedicated fashion. And that's the main difference as an AI product leader designing services now at a neocloud as compared to an hyperscaler.
Right. So I know that there are differences in how Crusoe has set up its networks, for example. Can you say exactly how that differs technically?
Yeah, I mean, first of all, the workloads are stressing the infrastructure differently. And then some of the classic requirements are not yet and may never be a matter that's important from an AI point of view. So if you let's look at this from a few different aspects. If you take the building to start with, a classic hyperscaler data center a few years down the road, not even 10, is designing for 10, 15 kilowatt energy density per rack. If you take a GB200 rack, we're shipping those clusters every day, you're at 120 kilowatt per rack. So you need to completely reinvent the way you design the building, you source energy, you cool the whole system, and so on. Then from a configuration point of view, if I look at a GPU cluster, we don't need to break down GPUs in slices. Like a lot of the heavy workloads, both training and inference, think at a cluster level. That's why you saw architectures happening at a rack level with NVIDIA generations, as an example, right? So the whole virtualization and how do I split the resource to share it among tenants is a different equation than a general purpose cloud. you were talking about networking. A lot of the workloads right now are happening on a per data center basis. So the networking in between data centers, that's important. That can be helpful when you need to migrate data or you need to migrate workloads, but it is not as, it's a different set of requirements. Now, within the data center, you need your network to perform really, really well in order, for example, to give the latency people expect in inference, which immediately influences the perception of the user in terms of AI agent responsiveness. So we do a lot of InfiniBand and Rocky and design for that maximum speed. And it goes on and on. I can look at the software stack, obviously, on top of the infrastructure, hardware pieces and fleet management. You have an ever-changing landscape of drivers and firmware because those GPUs are still young products that are subject to a lot of updates. How do you maintain your fleet to the golden standard of the latest firmware? So that takes you into operation challenges and SRE challenges. So the whole architecture and the way you think of designing infrastructure to support these services is special in many ways as you specialize on the AI workload.
Wow. So at the same time, Google, obviously household name, how does a neocloud company gain enterprise or IT organizations' trust, given how well established companies like Google and Microsoft and Amazon are in their minds?
Yeah, I think today people want to engage with neoclouds because they're doing AI in production at scale. And for them, speed and cost is critical. You know, we serve companies like Cursor in the code assistant space, or Figure AI in robotics, or labs who build world models like Odyssey, inference specialized providers like Fireworks. All these people have one thing in common. They're in production at scale.
Yeah.
And so if you can give them a time to market advantage because you're able to make a given feature or a given piece of hardware available earlier, or if you can give them a cost advantage by giving them the same performance they've had so far in inference, but for a fraction of the cost, you directly inform their cost structure at scale, because in an AI agent business case, inference is actually the number one cost. So I think engaging with neoclouds is a way to engage with people who do AI only, are most likely at the edge of innovating, pushing the limits of these systems, and will want to give you the best time to market and the best cost structure. I think what is special about Crusoe, when you think of that lens, is that we source energy, we develop data centers, we build cloud services. So I think we have a pretty unique advantage in understanding the cost structure top to bottom and building one that's going to be relevant even a few years down the road, right? You can take a colo data center today that was built for general purpose cloud. You can put some GPUs there, but eventually at some point, you're going to have a challenge of the building not being able to keep growing with the generations of hardware. Similarly, if you have a data center, but you don't have an ability to increase the energy intake because you don't fully understand the energy supply chain, you may not be able to unleash the power of those GPUs. So I think the fact that we have expertise and do source energy, develop data centers, develop cloud services is eventually translating into speed and cost benefits for our clients.
What kind of cost benefits can you offer? How much can people save versus a general purpose service?
Yeah, I think it's a very general question. But let's take an example. You need to inference a model because you build an AI agent, and that agent is inferencing a model that eventually happens to be the biggest cost in your operation. If I can allow you for a fraction of your cost to improve drastically your time to first token, so the speed at which the model responds, or if I can have more concurrent users on the same hardware fleet, and I can have more of those concurrent users, eventually I'm helping reducing your cost in production. So we've published benchmarks. I take a standard model anybody can play with, Llama 7TB from Meta as an example. If I take that model and I inference it with a standard inference stack, something like VLLM open source as is, And in contrast to that, I inference it on Crusoe Cloud with our understanding of the cost structure and our inference engine we built in-house. I'm going to be able to give you 5 times more throughput, 5 times more token per second. So that could translate into very substantial savings for your AI agent.
Right, right. And then, of course, it's no secret that AI data centers demand huge amounts of power. And Crusoe calls itself an energy-first company and focused on sustainable energy sources. So, how do you go about doing that, and how do you keep those costs manageable?
So let's start with what's really visible about this. Like if you take this Abilene campus you were referring to earlier, so we built that 1.2 gigawatt campus for OpenAI as part of Project Stargate. Why is it in Western Texas? Because we advised OpenAI to execute that development in an area where the grid, the electricity grid, is very rich in solar and wind. If you ever go visit in Abilene, it's a really windy place. And so we tend to, because we have in-house energy sourcing competencies, we can help select the sites where we're going to get some unique energy attributes. Another example, we're working with a company called Redwood Materials in not so far from here. I'm in California today, in Nevada. They basically use EV batteries that are not good enough anymore to be in a car, but can still have a lifetime powering other applications. And so we have a whole field of those EV batteries that have been decommissioned from cars. And now we're coupling them with a solar farm, and we're able to power mini data centers. So we have AI modular data center. That's how we call them. It's a product we call Spark. Think of that as a big container that you can put on a truck trailer, and in there you have 0.5 megawatt of AI compute capability. That has been designed by Crusoe. We have hardware engineering and actually manufacturing capabilities ourselves, and it's the densest modular AI data center you can find on the market today. Now, when I take that device and I want to power it with an energy that's more sustainable, we're able to partner with Redwood Materials, and we have 2 of those Spark units in Nevada, who are very helpful to kick off a new campus and get some compute available before you build bigger, or can be helpful for an inference use case, or can be helpful for a customer who'd say, can you give me my own region? Can you commit that I'm on the only tenant and everything is happening in this geography? And so we can drop those modular data centers and serve that need. And actually, if we find a sustainable energy source around, we can take advantage of it. So to me, it's really about putting those skills together in a room. When you think of sourcing energy, you're thinking in years, right? Years ahead, you need to think of getting the permits and powering and get the gas turbines and finding the wind turbines. When you think of building data centers, we're now thinking in quarters. We built the first tranche in Abilene for OpenAI in 11 months, which seems like a new world record. And when you think of software, as you and me know, you think in weeks, actually days, right? You churn software quickly. So you have 3 different industries that progress at different paces that you need to synchronize. And that's where I'm frankly learning every day. And I'm delighted that I have peers at Google who know that we should buy gas turbines today to power our data centers in 27. I have real estate and data center development folks who very well understand what it takes to turn on 200 megawatt in less than a year. And of course, we have the software engineering. And it's quite fascinating that if you don't align those 3 dimensions together, you may have a miss. So it's a very interesting equation to try to solve.
Absolutely. And I don't know that there have been too many companies that have really been thinking about things all the way from software as a service to power sourcing, would you say?
I think it's very unique. I think you're right, Beth. When I look at the clients we have as Crusoe as a whole, people who come to us to develop a data center very much value the energy pipeline, because that's the long pole in the tent. Like right now, we've publicly shared we have a 45 gigawatt energy pipeline. Like we're in touch with energy supply at that scale. So when you come to us to build a gigawatt data center, we have a very good insight on how to triangulate the geography, the location with the energy sourcing. And so I think it's pretty unique. And of course, we use that for our own benefit, for our own Crusoe Cloud services. And that's where the vertical integration will deliver the speed and cost advantage we were talking about.
So where do enterprise IT buyers factor into this? You mentioned companies like Cursor, but as far as more kind of mainstream customers, are they likely to engage with you more on that cloud services side? Are they going to be getting into, building data center infrastructure or renting that space from you?
On the data center side, the conversation is very, very specifically with frontier labs who have very, very out of the ordinary needs and hyperscalers. On the cloud services side, we see enterprises coming our way. For example, we've been working with Sony, helping their research and development team who are developing AI capabilities, which then get picked up by the different business units within the Sony Galaxy. I think we have a lot of those researchy type engagements. I think as far as production, there's a lot of enterprises who are still trying to figure out, do I build or do I buy? And so when we support a Cursor, we help a lot of enterprises indirectly because the Cursor finished product is going to be referenced by an enterprise to help their developers move faster in software development. I think we will see more and more enterprises wanting to manage that stack and to manage the optionality as opposed to buying a fully packaged product. I think we will see a lot of SaaS companies reinventing themselves with that AI agent era and wanting to understand the stack in more details. And that's why we're preparing, or we started releasing managed services. For example, you build an AI agent, you start from, say, DeepSeek, you tune it with your data, you distill it so that it excels at a given task in your workflow. Well, you can give us that model and we'll serve it back to you as a managed endpoint. So it's an API endpoint. You have an SLA around latency, query per second, and you don't need to worry about anything else. You don't need even to be involved in picking the type of GPU. We're optimizing the whole thing for you. We're giving you an SLA. You can sleep peacefully and focus your developers on augmenting the agent capabilities, understanding the workflow better, really focusing on your knowledge of the business problem you're trying to solve. Will take care of the infrastructure. And that managed inference service with a bring your own model flavor is something we're now shipping routinely starting this month, February 26th. We see a lot of companies who really are keen on open models because if I take an open model, I can modify it with my data. The derivative product is mine and mine only. That's my IP. And because it's an open model, I decide when I retire it. You know, it's not a model lab who's going to change the model under my feet and possibly impair my agent behavior. I have full control. And so we did build that product for that audience. You like an open model, you tune it with your data, but you don't want to turn every knob of the infrastructure stack to optimize inference. We can do this for you as a service.
Wow, okay. Now, given that the enterprise still hasn't fully come online with AI yet, this is a crazy question when you're talking about 45 gigawatts of power, but will that be enough? Will the tech industry as a whole be able to meet the demands for AI data center resources? Do you think it's possible?
I think that 45 gigawatt is a very, it's honestly a very amazing number for a company like Crusoe. But of course, it is an under representation of the need, right? There is demand for much more. I think power is eventually what's stressing the supply chain the most. You know, a couple of years ago, we were talking about, can you get your hands on GPUs? It is still true, right? At any point in time, when we put our hands on a new set of GPUs, they sell very quickly. But eventually, if you think of the most critical factors, energy is now the critical one, then is data center space, then is AI purpose-built hardware. And so energy will be a big deciding factor on the speed at at which the industry can deliver.
Mm.
As Crusoe, we're trying to deliver our share. It's a giant market. We're trying to
Mm.
be a predictable partner. When we tell you we can turn on the data center, we've checked the energy thing. We've checked the design so that we can deliver on the timeline. But simultaneously, I'm hopeful that we will continue seeing efficiency gains on the hardware and the
Mm.
models.
Mm.
I think not everything is a nail for a big model. That's why we're releasing tools to help you specialize a model. Distill it is the technical term to
Mm-hmm.
make it excel at certain tasks. That lighter model is going to give a faster response to your end user, but also consume less infrastructure and consequently less energy. So we have a bunch of levers to play with.
Mm-hmm.
Energy supply, designing with hardware that gets more efficient, and then the whole software stack and everything we can do on the model side. And frankly, it's an everyday task. I don't think we're going to be done in a year from now. We need to continuously innovate to optimize that equation and reduce the energy consumption footprint.
Yeah, I mean, what kinds of changes are you envisioning to that energy supply chain to accommodate all this? What's the biggest challenge and what's the biggest opportunity there?
Well, from a technology point of view, there are some very promising developments happening, for example, around SMRs and nuclear energy. Obviously, these things take a while because we need all of us, citizens, individuals, father, mothers, we need to be comfortable with nuclear happening in that sort of operation, as opposed to the applications we've known it for. But that's a very important development area to improve the supply and the sustainability aspect of things.
Mm-hmm.
There are also a lot of things we can do around the design of these data centers. I'm a software guy. I joined this company with a lot of software background. I'm absolutely amazed with the way the design of the data center can still present a lot of optimization opportunities. And so if you look at a campus like the one in Texas, you have 8 very big buildings, and they were not all built at the same time. The first one was built and so on. And it's very clear that we're able to learn at every building how to improve the design for the next one. And that includes energy consumption, which is a very, very important aspect. So I'm very excited about the data center design aspect of things, because there is a true, genuine opportunity to reinvent how you build a data center. It's not an option, actually. It's not a marginal improvement. If you don't design the data center for AI, you're extremely inefficient. And so I think that's another area where we'll see innovation. And then I think on the model side, I've been really pleased with the uptake of the open models. I distinctively remember, I think it was late 23, Llama 7TB, Llama 3 coming out of the gate. Since then, we've seen many more models. And I think open models will eventually drive or help the specialization of model and consequently the reduction in their size, so that not everything gets addressed by a big hammer, big model.
Right.
And to me, these are the 3 levers, right? You try to be smarter in energy sourcing and explore, qualify new energy sources, and you do it responsibly. You optimize the data center design, and then you look at all the software improvements. And we'll need all of this if we want to stand a chance to address all the need, all the demand.
And at the same time, given how rapidly this is all changing, but how slowly things like the power grid building and even enterprise adoption of new software and hardware can happen, there's going to be a long tail too, right, of sort of previous generations as new ones get built out. So how do you manage that sustainably?
Well, there are opportunities to retrofit existing data centers to make them work best for AI. It's not an easy task, financially, as an example. However, I think we want to keep an eye on the granularity of the cloud infrastructure for AI. Today, there's a lot of focus on those gigawatt scale data centers, which address the big training lab needs, which give you economies of scale when you perform inference at very large scale. I think there is a case for inference at the edge. So overall, training and inference, the tide is shifting this year on a global basis. More workloads on inference than training. Since then, training was the dominant workload. Why is that? Because end users are adopting, and each time end users adopt, they prompt the model responds. That's inference. So with inference becoming the larger share of the overall traffic, what do you care for inference? You care about the cost, you care about the concurrency of users, and you care about the latency. So there is a case for inference at the edge where you bring the infrastructure closer to the user base to be able to serve with a better latency. And there you could use inference specialized chips that are going to improve the energy consumption for that workload. And I think that's gonna be an important part of addressing the growing demand. And when you go with a smaller data center at the edge, you have many more options energy-wise, like the one I was describing to you with Redwood Materials as an example, right? It's one of those modular, small-size data center. I think we have a lot of options there to optimize not only the energy bill, but also the user experience. And I think you need that to make sure the industry embarks on this. You need to have an improved performance and improved user experience resulting from that sort of deployment. And then you'll collect the other benefits.
All of that is just a lot to take on, but is there anything else that should be top of mind for IT organizations as we enter this brave new world?
Yeah, I mean, I think that if AI is starting to become a very substantial workload as you look at your cloud bill, if you decide to build and not only to consume an agent built by somebody else, I think it's probably wise to look at neoclouds, to look at the increment of cost and speed you can get from them. That's maybe one takeaway. The other one is, as an industry, all of us, and especially if you, just like myself, have been predominantly in software, taking hardware and infrastructure for granted, well, it's kind of fascinating to try to connect the dots between energy supply, data center development, cloud services development. At Crusoe, that's our daily life, and I've been personally learning and growing a lot from this equation. So I think it's a really fascinating topic to follow. It's a humbling topic. We have many answers we need to define, but it's really pioneering type work and very, 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 very interesting to study.
Absolutely. Well, thank you so much for taking the time to chat, and I appreciate your insights.
Thank you, Beth. Thanks for having me.
Thank you for tuning in to IT Ops Query. To learn more about enterprise software development and platform engineering, explore our content on Informa Tech Target sites. Find us on YouTube at our channel, Eye on Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Thank you for joining us.